To today's tutorial. Kindly subscribe if your friends subscribe, so that every time we post a new tutorial, you are the first to get the notification. So welcome for today. Today we want to look at the solution to linear differential equations. Solution to linear differential equations. So welcome. A general first order DE on differential equation is of this form. So this is actually the first order linear DE. So our first order linear DE is of this form, whereby the coefficient of dy dx is not w. So I mean it is not 0. It is not 0. It is not 0. Because if it is 0, then when we do this division here, we will find that it will not give us a defined answer. So where the coefficient of dy dx is not 0, so that's a1x. So what we are doing, we are dividing every part by a1 divided by a1 so that now we get this kind of equation here, get that kind of equation there. So we can write above as this, meaning x divided by a1x, we can call it a function of p. Then the solution here is actually what we are calling gx. So we have tried to write the linear DE into that form. So next we want to now to transform or to solve this that equation by introducing a function ux. So we introduce a function ux in which we multiply every part using the concept of integrating factors. Remember from my previous tutorial, I looked on how we use integrating factors to change a DE from a normal DE to exact DE, so that we can be able to solve it. So if you have not looked at that, kindly look up there, the link above, so that you can check for the audio the tutorial that I looked at. So in that case, applying the idea now of solving exact DEs, this follows, and we know from that we substitute that, and after that we are able now to solve this equation. So if we do that, we differentiate that and we equate that to that, you'll see that our px will be like that. And then if we want to get px, ux, which is not differentiated, we integrate that. Remember, this is just from rearranging that. So that from that we come up with this kind of relationship, and applying exponential both signs, we'll find our ux is given in that form. Therefore, our ux given, substituting down and back there, you can see we have that, and if we multiply by dx, you'll find that this is true. That is true. So we integrate both signs and we get this general solution. And general solution. Get that general solution. So let us look at an example so that we follow those steps one by one. So we have solved dy dx minus 5 of xy equal to negative 5x. So if you look at this one, this follows the format of linear DE. It's only that our a1x is actually 1. It should be here. Then our a not x is basically 5 over y, and our other part is that one. So now solving this, we have to identify px, and the px is obvious, that one. So our px is that. But we know we have also to get an integrating factor that we are calling ux. And from our relation, what we have just noticed that it is equal to that. So now substituting respectively, we have that, and integrating respectively, we also get that as the solution. If you have some questions on how we integrate this kind of equations, kindly leave a comment. I'll be back to you and I'll be able to show you how we do this kind of integration. So next we have this equation here. So our u now is x power negative 5. So substituting respectively, we have that. Then open the brackets or parentheses, and you'll see that this is true. You open and multiply by dx. Opening and multiplying by dx. Then after that, what we need to do is to get integral both signs. Remember, our interest is to come up with a solution in a form of y equal to something, a general equation. So after integrating this, that is true, because this literally cancels that. Okay, then this gives us this. Then we divide. We divide all this. We divide by x power negative 5. So that now we have this. And this is basically the solution that we expected. So if you have question on either of the part of this topic, kindly leave a comment and I will be able to respond immediately. So in the meantime, kindly subscribe and also share with your friends so that they get this knowledge. Okay, so bye for today. Until next time.